adding radicals. It's a lot like combining like terms. You can add x plus a 2x, but you cannot now add an x and a y. So you can add 3 square roots of 5 with 1 square root of 5, and you would get 4 square roots of 5. But if you had 5 square roots of 7 and you tried to add a square root of 6, there's nothing you can do with that. That's just like trying to add 5x plus y. So when you get something like this, you can't immediately say it cannot be simplified. First, you have to simplify each individual radical to see if maybe you can get the same radicand. You can only add when you have the same radicand and the same, think about it, what else? The same index. So I'm going to convert this root 20 into a root 4 times a root 5 and see that I actually have a 2 root 5. And then I can add a root 5. Okay, so root 20 plus root 5 actually simplifies to 3 root 5. 12 root 7 plus root 28. So root 28 is really a 7 times a 4, so it's really 2 root 7. So 12 root 7 plus 2 root 7, so I'll get 14 root 7. All right, root 26 plus root 15. I'm trying to find perfect squares within those. That's not working. This just cannot be simplified because they're not the same radicand. All right, square root of 64 plus cube root of 64. Well, that's why I mentioned this up here. This cannot be simplified because they're not the same index. Because, by the way, this is 8 plus 4. So that's 12. When I add these, does it give me 144? No, it gives me 128. And would I say it's a square root of 128 or the cube root of 128? I wouldn't say any of that. Oh, God. Okay, it has to be the same radicand, but also the same index. So let's practice this. We're going to do a combination of adding and multiplying. So we are distributing root 3 to the root 2. And then the root 3 to the 3. So I will get root 6 plus 3 root 3. That's all. All right, let's distribute this root 2 to the root 5. I'll get root 10. And then this root 2 to the root 10. And I'll get root 20. I'm not done. I cannot add those. I know you're excited about like maybe some root 10s hiding in there. Nope, it's not working. But what I can do is I can further simplify my root 20. That turns into a 4 times a 5, so it's root 10 plus a 2 root 5. That is now simplified because I cannot take, I look at my radicands and I cannot take any perfect squares from those. All right, one final practice. Square root of 21 times root 6 plus root 14 plus another 3 root 14. I cannot combine these because they are, one of them is in a parentheses. So my root 21 times my root 6 plus a root 21 times a root 14. I'm not going to multiply those out yet because I'd rather break down rather than build up. So this is 7 times 3, this is a 3 times a 2, this is a 7 times a 3, this is a 7 times a 2, plus this 3 root 14. Okay, so these are all in the square root. So, okay, so a 3 comes out and I get 3 root 14. A 7 comes out, I get a 7 root 6. And then I have the 3 root 14 that I was adding. Oh, hey, look, I can combine those. So 6 root 14 plus 7 root 6. Sweet.